latest studies from Mars images, rover images confirm the Jezero crater is an ancient Martian lake. Jennifer Chu, Massachusetts Institute of Technology article on phys.org. The first scientific analysis of images taken by NASA's Perseverance rover now confirms that Mars' Jezero crater, which today is dry and wind-eroded depression, was once in fact a quiet lake, fed steadily by a small river some 3.7 million years ago. You can imagine now the tremendous changes on the geology of Mars. Now, the images also reveal evidence that the crater endured flash floods as well. This flooding was energetic enough to sweep up large boulders from tens of miles upstream, depositing them into the lake bed where the massive rocks lie today. The new analysis published today in the journal Science magazine is based on images of the outcropping rocks inside the crater on its western side. Satellites had previously shown that this outcrop seen from above resembles river deltas on our Earth, where layers of sediment are deposited in the shape of a fan as the river feeds into the lake. Perseverance new images taken from inside the crater confirmed this outcrop was indeed a river delta. So based on the sedimentary layers in the outcrop, it appears that the river delta fed into the lake that was calm for much of its existence until a dramatic shift in climate triggered episodic flooding or towards the end of the lake's history. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. And here in the foreground, you see those huge boulders that seem to be a different color from what you have there as well. So if you look at these images, you're basically staring at this epic desert landscape. It's the most forlorn place you could ever visit, says Benjamin Weiss, professor of planetary sciences in MIT's Department of Earth, Atmospheric, and Planetary Sciences. He's a member of the analysis team. He says there's not a drop of water anywhere, and yet here we have evidence of a very different past. Something very profound happened in this planet's history. Of course, we're talking about Mars. As the rover explores the crater, scientists hope to uncover more clues to its climate evolution. Now that they have confirmed the crater was once a lake environment, they believe its sediments could hold traces of ancient aqueous life, and its mission going forward, Perseverance will look for locations to collect and preserve sediments. These samples will eventually be returned to Earth, where scientists can probe them for Martian biosignatures. So we have the opportunity to look for fossils. The team member Tanya Bosek, Associate Professor Geobiology at MIT, says it will take some time to get to the rocks that we really hope to sample for signs of life. So it's a marathon with a lot of potential. And they also, of course, found tilted beds. On February 18, 2021, the Perseverance rover landed on the floor of Jezero crater, a little more than a mile away from its western fan-shaped outcrop. In the first 3 months, the vehicle remained stationary as NASA engineers perform remote checks of the rover's many instruments. During this time, 2 of Perseverance cameras, the Mastcam-Z and the SuperCam remote micro-imager, or RMI for short, captured images of their surroundings, including long-distance photos of the outcrop's edge and a formation known as Kodiak Butte, a smaller outcrop that planetary geologists surmise may have once been connected to the main fan-shaped outcrop but has since partially eroded. Once the rover downlinks images to Earth, NASA's Perseverance science team processed and combined the images, and then they were able to observe distant beds of the sediment along Kodiak Butte in surprisingly high resolution. The researchers measured each layer's thickness, slope, and lateral extent, finding that the sediment has been deposited by flowing water into the lake rather than by wind and sheet-like floods or other geological processes. The rover also captures small tilted sediment beds along the main outcrop and these images, together with those of Kodiak, confirm that the fan-shaped the formation was indeed an ancient delta, and that the delta fed into the ancient Martian lake. Without driving anywhere, the rover was able to solve one of the big unknowns, which was that this crater was once a lake, Weiss said. Until we actually landed there and confirmed it was a lake, it was always a question. The boulder flow. When the researchers took a closer look at images of the main outcrop, they noticed large boulders and cobbles embedded in the youngest, topmost layers of the delta. Some boulders measured as wide as 1 meter across, is about 3 feet across, and were estimated to weigh up to several tons. These massive rocks, the team concluded, must have come from outside the crater and was likely part of bedrock located on the crater rim or else 40 or more miles upstream. So they're pretty big and heavy boulders. Judging from their current location and dimensions, the team says the boulders were carried downstream and into the lake bed by a flash flood that flowed up to 9 meters per second, so that's 20 some odd feet per second, moved up to 3,000 cubic meters of water per second. So that's a lot. They said you need energetic flood conditions to carry rocks that big and heavy. Weiss said it's a special thing that may be indicative of a fundamental change in the local hydrology or perhaps the regional climate of Mars. Because the huge rocks lie in the upper layers of the delta, they represent the most recently deposited material. The boulders sit atop layers of older, much finer sediment. This stratification, the researchers say, indicates that for much of its existence, the ancient lake was filled by a gently flowing river. Fine sediments, and possibly organic material, drifted down the river and settled into a gradual sloping delta. But the crater lake experienced sudden flash floods that deposited large boulders onto the delta, and once the lake dried up, and over billions of years, wind erosion eroded the landscape, leaving the crater we see today. The cause of this climate turnaround is not known, although Weiss says the delta boulders may hold some answers. The most surprising thing that's come out of these images is the potential opportunity to catch the time when the crater transitioned from an Earth-like habitable environment to this desolate landscape wasteland that we see now. These boulder beds may be records of this transition, and we have not seen this on other places on Mars, they said. So this is by Massachusetts Institute of Technology, by Nicholas Mangold, and it's on phys.org. Jennifer Chu, Massachusetts Institute of Technology. Please leave your comments. Thank you for your support. Google Mars, and I'll leave a link below for you for this. Tremendous amount of information if you just want to go around and just look at it. Let's see what this thing is. Look at this. It's very uniform in its width, isn't it? What is that? I never looked into this, but this is not very high definition. I think this is better high definition, but look at that. Very strange things there. You can see how high it is. This is the shadow of it. And let's go to the side here. Very strange. Look at this. Tu Vallis. Again, this is more high definition. This is older. Let's go see some of these outcrops here. Okay, this is a crater. These are outcrops. Let's go into the crater a little bit. Very strange that it's very uniformly round. Look at that. Beautiful. Let's turn it around a little bit. Isn't that something? Pulling out. Look at this flow here, or crack. What is this? Let's see. Okay, these are older images. It's not that high definition. This is more high definition, but look at this. strange that this seems to be an even elevation. And this has been left. Let's go to the crater and see what's in there. You never know what you can find. What is that? What is this? Oh, that's just, okay. But yeah, you can see that something must have, what are these striations that you have there? The striations means that something must have blown these things to make these flows towards the east part. Look at this. Okay, more flows there. And a nice crack right around there. More flows here. Let's go up to the flows over there. Very strange. Look at this. Cracks and scratches. More flows here. Very evident flows there. Where are those coming from? Okay, so I'll leave links below for you. You can, you'll find different, very strange things here. I remember I had gone to the one section where I showed you something that looked like gates. I can't remember where that was. And then we found one section that had the dimensions of the distances between the Great Pyramid of Giza and the Sphinx, and this distance between the Amphipolis tomb and the lion statue in Amphipolis, northern Greece, was the same distance of the Great Pyramid from the Sphinx in Egypt. And we found one similar situation here on Mars. So there's a lot of strange anomalies on Mars that we can find by looking through these things. Anyway, please leave your comments and thank you for your support.